Today, we're going to learn how to calculate the probability of compound events. You should be on page 28 in your notes packet. We have talked about compound events in the past. We know that a compound event is when more than one event is happening. So we have discussed this in terms of maybe rolling a die more than one time, or flipping a coin and pulling a card. So we've also discussed the difference between an independent event and a dependent event. Whenever we are calculating compound probability, all that we are doing is taking the probability of the first event and the probability of the second event and multiplying them together. Well, this is very simple for independent events because independent events are two events that have no effect on each other. So to find these, we would multiply the probability of A times the probability of B. It's a little bit more complicated for dependent events. It's still multiplying, but since the first event changed the outcomes for the second event, then you would multiply the probability of the first event times the probability of the second event after that first event happened. So let's look at what those mean. Our first examples say you roll a fair number cube twice. What is the probability of each event? Well, before we get started, let's first figure out if this is a dependent or independent event. So if we roll a fair number cube twice, would that be dependent or independent? Put your answer in the chat. We know that this is an independent event because if we roll a number cube and then roll the same number cube again, we have not changed any of the outcomes. So all of the outcomes are still possible. So for number 1, it asks us for the probability of landing on a 2 followed by landing on a 6. Well, what I want to do to solve this is to find the probability of a 2. Well, there is 1 2 on a number cube out of 6 total spaces. So the probability of landing on a 2 is 1/6. Then I want to find the probability of a 6. Well, again, there is 1/6 on a number cube out of 6 total sides. So the probability of a 2, then a 6, is the probability of a 2, which is 1/6, multiplied by the probability of a 6, which is also 1/6. Well, when I multiply with fractions, I multiply numerator times numerator and denominator times denominator. So 1 times 1 is 1, and 6 times 6 is 36. So the probability of landing on a 2 followed by a 6 is 1 out of 36. Now let's look at the probability of an even, then an odd. Well, the probability of an even number on a number cube is that there are 3 even numbers on a number cube, that's 2, 4, and 6, out of 6 total numbers. Well, 3 over 6 can be simplified to 1/2. Then I would need to find the probability of landing on an odd number. Well, there are also 3 odd numbers on a number cube because those are 1, 3, and 5, and that's also out of 6 numbers. Again, 3/6 simplifies to 1/2. So if I am going to find the probability of an even followed by an odd, I would take both of those probabilities, which in this case is both 1/2, and multiply. Well, 1/2 times 1/2 is 1 times 1, which is 1, and 2 times 2, which is 4. So the probability of landing on an even, then an odd, is 1/4. Now our last one for this section says the probability of 4, then 9. So I would want to start with the probability of a 4. Well, there is 1 4 on a number cube out of 6 total spaces. So the probability of a 4 is 1/6. Then we want to find the probability of a 9. Well, actually, if we think about a number cube, there are no 9s on a number cube. So that probability is 0 9s out of 6, which simplifies to 0. Well, if I want to find the probability of landing on a 4 followed by landing on a 9, I would take the probability of a 4, which is 1/6, and multiply by the probability of a 9, which is 0. 1/6 times 0 is 0, which means it is impossible for me to land on a 4 and then land on a 9. Now let's look at the next section. Number 4 says you flip a coin and roll a die. What is the probability of flipping a heads and rolling a 4? Well, first off, is this event dependent or independent? Put your answer in the chat. We know that this is an independent event because when we flip a coin, it is not going to change the number of outcomes when we roll our die. So the first thing we want to find is the probability of flipping a heads. Well, we know that there is one heads on a coin out of 2 total sides. So the probability of flipping a heads is 1/2. Then we also want to find the probability of rolling a 4 on a number cube. We know that there is one 4 on a number cube out of 6 total sides. So the probability of a 4 is 1/6. If we want to find the probability of a heads, then a 4, we're going to take these two probabilities and multiply. So we're going to do 1/2 times 1/6. 1 times 1 is 1, and 2 times 6 is 12. So the probability of a heads, then a 4, is 1/12. Number 5 says we are still flipping a coin and rolling a die. And we want to know the probability of flipping tails and rolling a number less than 5. So the first thing we're going to do is find the probability of flipping a tails. Well, we know that there is one tail on a coin out of 2 total sides, so that probability is 1/2. Then we want to find the probability of rolling a number less than 5. Well, all of the numbers less than 5 on a number cube are 1, 2, 3, and 4. So that is 4 numbers that are less than 5 out of 6. Well, I know that 4/6 will simplify to 2/3. So the probability of landing on a number less than 5 is 2/3. If I want to find the probability of tails followed by a number less than 5, then I'm going to multiply these two probabilities. So I'm going to multiply 1/2 times 2/3. Well, 1 times 2 is 2, and 2 times 3 is 6. Well, I know that this fraction can be simplified because I can divide both the numerator and the denominator by 2. And 2 divided by 2 is 1, and 6 divided by 2 is 3. So the probability of tails followed by a number less than 5 is 1/3. Now let's look at number 6. Each letter of the word assessment is written on a card and placed in a bag. What is the probability of picking 2 S's in a row without replacement? When we see this that says without replacement, that means that we are taking something out and not putting it back in. So is this a dependent or independent event? Put your answer in the chat. We know that this is a dependent event because if we take one of the S's out of the bag, then that is going to change the number of outcomes. So when we do this, we have to be very careful for our probability. So let's look at the probability of the first S. Well, that one's easy. We would want to count up the number of letters in assessment. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we want to know how many of those are S's. Well, there's 1, 2, 3, 4 S's out of 10. So the probability of the first S is 4/10. And 4/10 simplifies to 2/5. Then we want to find the probability of another S. Well, we remember that we took an S out because we are looking for the probability of 2 S's in a row without replacement. So that means when we took this first S, we did not take it back. So I'm going to look at the word assessment without one of the S's. Well, now there are only 9 total letters in the word. And because I took one of those S's away, there are only 3 S's in the word. So now the probability of the second S is that there are 3 S's left out of 9 letters left. 3 over 9 simplifies to 1/3. To find the probability of 2 S's in a row, I'm going to take both of those probabilities, so 2/5 for the first S and 1/3 for the second S, and I'm going to multiply them together. 2 times 1 is 2, and 5 times 3 is 15. So that probability is 2/15. Now let's look at number 7. There are 9 girls and 12 boys in Miss Johnson's class. She writes each of their names on a piece of paper and puts them in a bag. She is going to draw out 2 names to decide who will be the student of the week. What is the probability that she picks a boy's name first and then a girl's name? Well, let's look at our problem. We know that there are 9 girls and 12 boys. So in total, there are 21 students. If she is going to draw out 2 names to decide who will be student of the week, that means that she is going to pick one name and then another name. Because she's finding the student of the week, she's probably not going to put the first name back into the bag. So that means this is going to be a dependent event. So let's look at our probability. We want to look for a boy's name first, followed by a girl's name second. So let's start with the boy's name. If there are 12 boys in the class, then there are 12 names in the bag that are boys, and that is out of 21 names in the bag. Well, this can be simplified because both 12 and 21 are divisible by 3. So 12 divided by 3 is 4, and 21 divided by 3 is 7. So the probability of choosing a boy's name is 4/7. Now we have to be careful with the girl, because if Miss Johnson pulled a boy's name out of the bag, then now there are no longer 12 boys' names in the bag. Instead of 12 boys' names, there are now 11 boys' names. We did not change how many girls' names there were because we chose a boy's name first. There are still 9 girls' names in that bag. However, because we pulled one name out that was a boy, there are no longer 21 students. Now there are only 20 total students' names in the bag. So the probability of choosing a girl's name next is that there are 9 girls' names out of 20 names left in the bag. That cannot be simplified, so I would leave it just like that. So to find the probability of a boy name followed by a girl name, I would multiply 4/7 times 9/20. Well, 4 times 9 is 36, and 7 times 20 is 140. Both of these can be divided by 4. When I divide 36 by 4, I get 9, and when I divide 140 by 4, I get 35. These don't have any factors in common, so this is in simplest form. So the probability of pulling a boy's name followed by a girl's name is 9/35. Number 8 says a bag contains 3 green, 2 blue, and 5 yellow marbles. If Melissa randomly draws 2 marbles from the bag without replacing the first marble, what is the probability of drawing 2 green marbles? I want you to try this and put your answer in the chat. We know that this problem is a dependent event because we are not replacing the first marble. We also need to know how many total marbles there are. We know that there are 3 green and 2 blue and 5 yellow, which means that there are 10 total marbles to start with. We want to find the probability of choosing 2 green in a row, but we are not replacing the first. So we need to find the probability of the first green. Well, we know that there are 3 green in the bag out of 10 total marbles. So the probability of the first green is 3/10. But then we're going to keep that one out of the bag and try to choose another green. Well, if we take this one out of the bag, then there are no longer 3 green. Now there are only 2 green left in the bag. Also, because we took that out of the bag, there are no longer 10 total. Now there are only 9 total. So the probability of the second green is that there are 2 green left out of 9 total green in the bag. So the probability of 2 green in a row is going to be 3/10 times 2/9. 3 times 2 is 6, and 10 times 9 is 90. Both of these can be divided by 2, so 6 divided by 3, I'm sorry. So 6 divided by 3 is 2, and 90 divided by 3 is 30. Now, this is the biggest mistake I see with fractions. You looked at this and you said, you know what? I can divide both of these by 3, and this is my answer. Well, you have simplified it a little, but not all the way, because actually 2 and 30 are both even numbers. So both of these can still be divided. Both of them can be divided by 2. So 2 divided by 2 is 1, and 30 divided by 2 is 15. So really the probability of choosing 2 green in a row is 1/15. Now go to page 29. On page 29, you see number 9, which says oatmeal raisin and M&M cookies are randomly chosen from a cookie jar and placed onto a plate. The first plate had 4 oatmeal raisin cookies and 1 M&M cookie. A second plate was prepared with 2 oatmeal raisin cookies and M&M cookies, which means we don't know how many M&M cookies there are. If the probability of drawing an oatmeal raisin cookie from each plate is 8/25, how many M&M cookies M are on the second plate? Now, at first, this looks a little bit confusing. But if you pay close attention to this problem, it's actually not as difficult as it sounds. So let's think about this. We have a first plate, and on that plate, we have 4 oatmeal raisin cookies. So 4 oatmeal raisin cookies. But then we also have 1 M&M cookie. So we have 4 oatmeals and 1 M&M. Well, then we have a second plate. The second plate has 2 oatmeal raisin cookies, and then we don't know how many M&M cookies. But we know that together the probability of choosing oatmeal raisin is 8/25. Well, if I was choosing oatmeal raisin from both plates, I know that if I choose one from this plate, it is not going to affect how many are on this plate, because this plate has its own oatmeal raisin and this plate has its own oatmeal raisin. So this is actually an independent event. So all we have to do is think about this in those terms. I know that in my first plate, there are 4 oatmeal raisin cookies out of 5 total cookies. So the probability of the first plate getting an oatmeal is 4 out of 5. Well, I know that I would then multiply this by the probability of getting oatmeal on the second plate. Well, on the second plate, there are 2 oatmeal. But what I don't know is how many M&M cookies there are. But I'm going to use the variable M, which was in my problem, to represent my number of oatmeal, or my total number of cookies. I know that together I have a total probability of 8/25 because that is what my problem told me. Well, let's look at this. If I multiply 4 times 2, that's going to give me 8. And then if I multiply 5 times something, that's going to give me 25. Well, 5 times what gives me 25? I know that 5 times 5 gives me 25, so the missing number in this fraction is 5. Well, this means that 2 oatmeal cookies are on my second plate out of 5 total cookies. Now we have to be careful. That does not mean that there are 5 M&M cookies. That means that there are 5 total cookies. Well, if 2 of them were oatmeal raisin, then how many left are going to be M&M? There are going to be 3 left that are M&M. And now when I look at this plate, I now see that the probability of oatmeal is that there are 2 oatmeal out of 5 total cookies. So there are 3 M&M cookies on the second plate. All right, I want you to read number 10. Number 10 is very similar to number 9. I want you to try number 10 and put your answer in the chat. This says that a large pizza contains slices of pepperoni and slices of mushroom. Anthony randomly selects slices of pizza and places them on a plate. So his first plate had 2 slices of pepperoni and 1 slice of mushroom. So there are 2 pepperoni and 1 mushroom. A second plate also has 2 slices of pepperoni. If the probability of drawing a slice of pepperoni from each is 4/15, then how many slices of mushroom are on the second plate? So what we don't know is how many mushroom are on this plate. We know that the probability of getting pepperoni from both, so a pepperoni followed by a pepperoni, is 4/15. Well, the probability of pepperoni from the first plate is that there are 2 pepperoni out of 3 total slices. Well, we know that we would multiply that by the probability of pepperoni on the second plate, and that when we find this, we have a total probability of 4/15. Well, when I look at my second plate, I know that there are 2 pepperoni, so it's 2 out of, and what we don't know is how many total slices of pepperoni there are. Well, when I look at this, 2 times 2 is going to give me 4. So 3 times what is going to give me 15? I know that 3 times 5 gives me 15. Now we have to be careful because 5 is not the total number of mushroom slices on that plate. 5 is the total number of slices of pizza on the plate. So if 2 of them are pepperoni and there are 5 total, then the rest of them have to be mushroom. So that means that there are 3 slices of mushroom on the second plate. Now let's look at number 11. For number 11, you see a table that shows the result of spinning a color spinner. Your spinner has red, yellow, blue, or white, and we do this experiment 2 times. Each experiment you can see occurs 10 times. We're going to use the results from the table and find the probability of a spinner landing on red in experiment A and landing on white in experiment B. We want to also make sure we write our answer as a fraction, a decimal, and a percent. Well, when we look at this, we see that experiment A has 10 total experiments, and we want to find the probability of landing on red in experiment A. Well, in experiment A, I had landed on red 1, 2, 3 times. So the probability of landing on red was 3 out of 10, since experiment A had 10 trials. Then I want to know the probability of landing on white in experiment B. Well, for experiment B, we landed on white just 1 time, and that was 1 time out of 10 times. So if I want to find the probability of landing on red in experiment A followed by white in experiment B, I would take the 2 probabilities and multiply. So 3/10 times 1/10. 3 times 1 is 3, and 10 times 10 is 100. So this is 3 over 100. But we need to remember that the problem asks for our answer as a fraction, a decimal, and a percent. To change 3 over 100 into a decimal, we would need to divide. 3 divided by 100. Well, when we divide 3 by 100, we get 0.03. Then, to take our decimal and move it to a percent, we would multiply our decimal by 100, which is the same as moving our decimal 2 places to the right. Well, when we move this decimal 2 places to the right, it's going to end up right here behind the 3, which means this is 3%. Now let's look at number 12. Jeff has 2 paper bags. The first bag contains 3 marbles numbered 1, 2, and 3. The second bag contains 4 marbles lettered A, B, C, and D. What is the sample space? Well, if we think about this, we have a bag that has a marble with 1, 2, and 3. We have another bag that has a marble that has A, B, C, and D. So when I look at this, there are 3 outcomes in the first bag and 4 outcomes in the second bag. So the sample space is going to be 3 times 4, which is 12. If I need to list out all of the outcomes, I know that I could pull 1 from the first bag and either A, B, C, or D from the second bag. I also know that I could have pulled 2 from the first bag and then either A, B, C, or D from the second bag. I also know that I could have chosen 3 from the first bag and chosen either A, B, C, or D from the second bag. So this is a list of all of my outcomes. And when I look, I see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. We want to find the probability of choosing a 1, then a B. Well, if I look at my list, it actually makes it very easy for me. There's actually only one place that has a 1 and a B, and that's out of 12 total outcomes in my sample space. So the probability of choosing a 1 and then B is 1/12. If you can't see it in your list, that's okay, because you can also use our rule for compound probability. The probability of choosing 1 from the first bag is that there is 1 out of 3 marbles. And then in the second bag, there's 1B out of 4 marbles. If I multiplied those together, 1 times 1 is 1, and 3 times 4 is 12. So whether you use your list or you just use our rules for finding compound probability, you are still going to get 1/12. Part C says if Jeff puts all the marbles in one bag and selects marbles without replacement, what is the probability of a 1 followed by a B? So we're looking for this exact same probability, 1 then B. But this time, all of the marbles are in one bag. So let's look at what this would look like. We know we have 1, 2, and 3, and we also have A, B, C, or D. And now instead of being split up, they are in one separate or one bag together. Well, if he's going to put all the marbles in a bag and select them, we want to find first the probability of a 1. Well, when we look, there is still only one marble that it has a 1, and that is in this time out of 7 total marbles. But it tells us that Jeff is not going to replace that marble. So if he has pulled the 1 out, then it is going to remain out. And then we want to find the probability of choosing a B. Well, now there is still just one B, but instead of there being 7 total marbles, there are now only 6 total marbles. So the probability of a B is 1/6. So to find the probability of 1, then B, I would take the probability of 1, 1/7, and multiply it by the probability of B, 1/6. 1 times 1 is 1, and 7 times 6 is 42. So this is 1/42. Now question D asks, did this change from B? Well, yes, it definitely changed, because in B, the probability was 1/12, and in C, the probability is 1/42, even though both of them are asking for the probability of 1 followed by B. So yes, this changed. And the reason for this change is because in part B, this was an independent event. Because when I chose 1 from this bag, it had no effect on me choosing B from this bag. But in this one, when I took 1 away and did not put it back, this made my next outcome different. Instead of having 7 total outcomes, there were only 6. So this changed partly because they're all in one bag, but also because it went from an independent event to a dependent event.